In this lesson, we're going to be solving equations that look something like this. And I'm going to show you two methods, but before we begin, I really need you to remember, maybe you've never done complex numbers before, or imaginary numbers, but I just want you to remember the following. If you take the square root of -4, for example, and you type that on your calculator, it's going to give you an error. That is because you cannot take the square root of a negative number. So what you do instead is you go into the imaginary numbers, and the way that you do that is you just rewrite this as square root 4 multiplied by square root -1. Because that's how square roots work. For example, if you take square root 3 times square root 5, then it's the same as square root 15. Okay? So what I'm doing here is I'm just splitting this up into 4 multiplied by -1. And then we know that the square root of 4 is 2, and then what we must know, that this is the only golden thing I need you to remember for me this lesson, is that the square root of -1 is called I. So as soon as you see a square root of a -1, you're just going to call that I. So we're going to go 2I, and that would be the answer for that part over there. Okay, so let me show you how to solve this. I'm going to be showing you two different methods because there are two different ways that teachers do this in different parts of the world. So the first way, this is my favorite one, is where you just take the 16 over to the other side. Then you're going to square root both sides, okay? So you're going to square root both sides, always remembering to say plus and minus for this one over here. And so on the left, you're just going to end up with x. And on the right, you're going to get an error if you try to type that on your calculator, because you cannot take the square root of a negative number. So what you do is you rewrite it as that and that. And then all of a sudden, we know that the square root of 16 is 4, and the square root of -1 is called I. So you're just going to do that. And there's your two answers, positive 4i and negative 4i. Okay, the second method that some teachers like to use is where you make two brackets. And all that you're going to do, okay? Another thing I need you to remember for this lesson, we have spoken about this before, is that I squared is equal to -1. If ever you see I squared, just make that -1. So these are the two main things you must know. I is equal to, what am I doing? Oh no, that was right. I is equal to the square root of -1, and then I squared is equal to -1. Okay, so what some teachers like to do is they use the sum of squares method. So you put an x over here and x over here. The square root of that is 4 and 4. And then they say plus and minus, but you got to put an I over there, and you got to put an I over there. Okay, and then if you then had to go solve that, I'll show you now how this actually works. But if you had to go solve that, you would say that x plus 4i is equal to 0, or x minus 4i is equal to 0, and so x is going to be -4i, or x is going to be positive 4i. And that's what we got here as well, plus and minus 4i. Okay, but Kevin, how does this method actually work? Okay, let me show you. So you remember back in the day we were doing difference of squares. That was the one where you would have something like x squared take away 25. Okay, and that's where we said that you have to have three different things. You have to have, number one, you have to have two terms. Number two, they have to be separated with a negative. And number three, each term must be a perfect square. Okay, and with those ones, what we used to do is we just used to make two brackets, and we just used to say x, and then we would say plus 5 and minus 5. But that doesn't work when there is a plus in the middle. You see, we have got two terms. They are both perfect squares, but they are not separated with a negative, and that's the problem. They're separated with a positive. So what we do is we still do the normal x plus 4, x minus 4, but then you just add an I to that one over there, to both of those. For method number 2, I also need you to remember that I squared, I did show you this in one video when we were doing complex numbers, but I squared is equal to -1. Okay, so those are the two things you have to remember in this lesson, that I is the square root of -1, and then I squared is -1. Okay, can you remember when we were doing the factorizing of difference of squares? You know, like if you have x squared take away 25. And we learned that if you have two terms separated with a negative, and each term is a perfect square, then what we would do is we would then go ahead and make two brackets, and then you would say x and x, 5 and 5, and then the one would be a plus and the other would be a negative. That was difference of squares. We call it difference of squares because it's got a negative. But now we have a sum of squares, and unfortunately you can't just say that that's going to be x plus 4, x plus 4. I know a lot of you are thinking that, but that doesn't work. So what you do instead is you pretend that it's a difference of square. So you just go do the whole, let me just make some space here. You do the whole x, 4, 4. You can make the one a plus and the one a negative. You're still going to do that. But then what you're going to do to this number, the 4 and the minus 4, is you're going to add an I and an I. Okay, that's what you're going to do. So whenever there's a plus in the middle and you've got two terms separated with a positive, and each one's a perfect square, then you can just use this technique over here, where you're still going to use a plus and a minus, but you're going to add an I. Now let me show you how that actually, or let's first go solve. So you would then say that x plus 4i is equal to 0, or x take away 4i is equal to 0. So this first one, you'd end up with x equals to negative 4i, and the bottom one, you'd end up with x is equal to 4i. So we're getting the same answers, but let me show you how this actually makes sense. So if you had to go multiply these two brackets together, let's see what would happen. So let's quickly write this over here. So that the question is done, but I'm just showing you how this works now. So if you had to use FOIL, you would do first times first, which is x squared, outer times outer, which is negative 4ix, inners times inners, so that would be plus 4ix, and then the last times the last, so this one and this one. So that's going to be negative 16i. Now I times I is I squared. Now if you look at these two middle terms, they cancel out. And if you look at I squared, we said that that should be negative 1. So we're going to say x squared minus 16 in brackets, negative 1. And so that's going to give us x squared plus 16. And that's exactly what we had. So here's our first official example. That was just like a practice one in the beginning. Now we're going to go through the exercises. I'll do both methods for you. So for the first method, which I love, is where you just take the 9 to the other side. Then you take the square root on both sides. So square root and square root, and then you say plus minus. Then x equals to plus minus. Now square root of minus 9, it'll give you an error on your calculator, so you rather do it like that. And then just remember that these are the rules that I want you to remember for this lesson. Okay, so then what you end up with is x is plus or minus, the square root of 9 is 3, and the square root of minus 1 is called I. And so there's the answer. Done. I love that method. If you want to use the difference of square, or the sum of square, sorry, because maybe that's what your teacher does, then I hear you. So what you then do is you say x and x, 3 and 3, plus and minus. But because it's a plus in the middle, we have to add I and I. And so we're going to say x plus 3i equals to 0, or x minus 3i equals to 0. And so x would be negative 3i, or x would be equal to positive 3i. With this one, what we must always remember is that this is not a difference of square. It's not a sum of square. These are pretty ugly. Like, you can't factorize. I mean, you can't. That's not a difference of square or anything like that. So it's not a perfect square. That's what I'm trying to say. So remember the golden rule of factorizing. What should you always do? Always see what you can take out. So you can actually factorize a 2x out of here. So you could take out a 2x, because this one's got x3, this one's got x. So you can always take out the lowest one. And then you're going to be left with x squared plus 16. Okay, there we go. And now, now with this one, this is actually very interesting. Oh, no, actually, never mind. So now what we'll do is we'll say that, so here you can think of this as a bracket. So here we could say that 2x is equal to 0, or x squared plus 16 is equal to 0. Or actually, let me now break this up into option 1, option 2. This is where we need to break it up. option 1, option 2. Okay, so for option 1, it's where we just say that 2x would be equal to 0, or x squared plus 16 will be equal to 0. And so for this one, you're just going to end up with x equals to 0. And then for this one, you're going to do the whole, take the 16 over to the other side. Then write it as, we're going to square root both sides. Always say plus minus over here. Why am I saying negative? Oh, no, it was negative 16, hey. Okay, and then you're going to say x equals to plus minus the square root of 16 multiplied by the square root of minus 1. And so that's going to end up becoming plus minus 4. And then the square root of minus 1 is I. Okay, so there's your 3 answers there. And then there's 2 answers there. Positive 4i and negative 4i. For option number 2, you could then factorize this as a difference of square, or a sum of square. So you could say x, 4i, 4i, one's a positive, one's a negative. And so then you could say 2x is equal to 0, or x plus 4i equals 0, or x take away 4i is 0. And so here for this one, you're just going to get x equals to 0. For this one, you're just going to get negative 4i. And then for this one, you're going to get x equals to 4i. Last example. So step 1, always see if you can take something out. So here we could take out a 5x squared. And then you'd be left with x squared plus 9. Okay. And so there we have it. So for option 1, and then for option 2. Okay, so for option 1, you would just say that 5x squared. Remember, as soon as you've got brackets like this, you can just make them equal to 0. So you'd say 5x squared equals to 0, or x squared plus 9 is equal to 0. For this one, you're just going to divide by 5, take the square root, but you're just going to end up with 0. And then for this one, you could say x squared is equal to negative 9. Take the square root on both sides. Say plus minus, and so x would be equal to positive or negative, and then the square root of 9 multiplied by the square root of negative 1, and so x would be plus or minus 3i, because square root of negative 1 is I. So there's your 3 answers. X is 0, x is 3i, and x is negative 3i. In option number 2, I'm going to write this a little bit higher. You're going to have 5x squared multiplied by x squared plus 9 equals 0. And so you can first factorize this a little bit further. So you could say x 3 and 3, and then I and I, because it's a plus in the middle and not a minus in the middle. If it was a minus in the middle or negative, you wouldn't be putting the i's. And then you're going to say equals 0, plus and negative. Okay, so now what we do is we can say that 5x squared is equal to 0, or x plus 3i is equal to 0, or x take away 3i is equal to 0. And so we now end up with x is 0, or x is negative 3i, or x is equal to positive 3i.